Greetings, beautiful people. Welcome back to this channel. We are still in the season of circle theorems, and today we have a cyclic quadrilateral theorem. But before we begin, what is a cyclic quadrilateral? What is a cyclic quadrilateral? A cyclic quadrilateral is a four-sided shape that is drawn inside a circle. The four-sided shape has to be drawn inside a circle. The condition is that all the vertices has to touch the circle. All the vertices has to touch the circle. It means that for a shape to be called a cyclic quadrilateral, it has to be a four-sided shape, and all the four corners or the vertices has to touch the circle. So let's begin by drawing our circle. Draw a circle with a radius of 5. We have a circle. Now we are going to draw a four-sided shape where each of the corners must touch the circle. The first, so we connect them. Then we draw another, connect them, draw another one, connecting them, then we draw. We have 3. Let's connect the 2 points to form a four-sided shape. Now this is what I mean. You realize that these points are all touching these corners. They are all touching the circle. In this case, the shape is called a cyclic quadrilateral. Now we are saying that in a cyclic quadrilateral, opposite angles are supplementary. Now what are supplementary angles? They are angles that add up to 180 degrees. 180 degrees. Now what are opposite angles? Opposite angles are angles that are facing directly to each other. They are facing each other. So this is opposite to that, and this angle is also opposite to that. Now we are saying that these two angles must add up to 180 degrees because they are supplementary. So let's measure the angles and check whether they are indeed supplementary. So we have angle BCE that is giving us 98.1. Let's measure the opposite angle, which is angle EDB, that is giving us 81.9. Now let's add the two angles. So let's add the two opposite angles to verify whether they are supplementary. So angle BCD is 98.1 degrees, and an angle EDB is 81.9 degrees. Now adding 1 plus 9 will give us 10. So we'll add it to the next one. Then 8 plus 1 will give us 10. Right, so we add it to the next one. Now we have 9 plus 8 plus 1, that will give us 18. So we have 180 degrees. Let's measure the other opposite angles. So we have angle CBD, which is opposite to angle CED. You can clearly see the two angles are supplementary. 90 plus 90 will give us 180 degrees. That is a cyclic quadrilateral theorem. Now, a key reminder is that make sure that the four corners are all touching the circle. The four corners must all touch the circle. I repeat, the four corners must touch the circle. It doesn't matter where they are touching it. If they are all touching the circles, the theorem will work. Let's move the points around to verify how these things work. So if I move this corner, check the opposite side. Do you see that the opposite sides are all giving us 180 degrees? So let's move it around. So if this is 87, its opposite angle will be 93. When we add 93 degrees plus 87 degrees, we are going to get 180 degrees. So in a cyclic quadrilateral, opposite angles will always add up to 180 degrees. Thank you for joining me, and we'll meet in the next video. Don't forget to subscribe, like, and leave a comment. I'm out.